Hello everyone and welcome to Pentagon. Here's today's problem. We have a rectangle with dimensions of 60 and x, with 60 being greater than x, and the diagonals of the rectangle are drawn. We also have a small line connecting one diagonal to another, forming a small right triangle with legs of 5 and 12. We need to find the length of the shorter side of the rectangle. Please pause the video here if you'd like to try and solve this yourself. Right. First, let's establish some relationships in this diagram. Now, since this is a rectangle, we know that its diagonals are going to bisect each other. So, for example, this part of the diagonal is congruent to this part of the diagonal. Right? But since it's a rectangle, we also know that the diagonals are congruent. So all of these halves are going to be congruent. So these are all congruent to each other. Next, let's label some angles. Let's clear this space. Let's call this small angle right here, let's call that 2 alpha. And you'll see why I'm multiplying it by 2 in a bit. Alright. Now, if you look closely, you can see that we have an isosceles triangle here. And we know that the base angles of an isosceles triangle are going to be congruent. And since the sum of the measures of the angles in a triangle is 180 degrees, we can write an equation to solve for these angles. So let's call them y, and let's write the following equation. 2 alpha plus y plus the other angle y is equal to 180. If we subtract 2 alpha from both sides, we get y plus y, or 2y, is equal to 180 minus 2 alpha, which means that y is equal to 90 minus alpha. So this angle is equal to 90 minus alpha. But now look what we have. We also have a big right triangle here. Right? And this is a right angle. Now we know that the two angles other than the right angle in the triangle will sum to 90. They're complementary. So if one of the angles is 90 minus alpha, then the other angle must be alpha. Alright, now we're going to use a bit of trigonometry. Let's try to find the tangent of alpha. Now, in a right triangle, the tangent of an angle is going to be a fraction, and in the numerator is going to be the measure of the leg opposite the angle. So, in this case, the leg opposite alpha has a measure of x, and in the denominator is going to be the measure of the leg adjacent to the angle. So, in this case, the leg adjacent to alpha has a measure of 60. Alright. Now let's do the same with the angle measuring 2 alpha. Right. In the numerator is going to be the leg opposite 2 alpha, so that's going to be 12. we're using this small right triangle here. Right? And on the denominator is going to be the leg adjacent to 2 alpha, which is going to be 5. Alright, now we're going to use a small theorem, which I'll write up here. The tangent of any angle, let's say theta, is equal to the sine of that angle divided by the cosine of that angle. So let's use that with the second equation that we established. We can say tangent of 2 alpha is equal to the sine of 2 alpha divided by the cosine of 2 alpha. Now we can actually rewrite the numerator and denominator as follows. Sine of 2 alpha is equal to 2 times sine alpha times cosine of alpha, and the denominator we can write as follows. Cosine squared of alpha. This just means take the cosine of alpha and then square that, times sine squared, oh, my mistake, it's minus sine squared of alpha. Alright. Next, what we'll do is we'll divide the numerator and denominator by cosine squared of alpha. So let's do that. We'll have this equal to 2 sine of alpha cosine of alpha divided by cosine squared of alpha, and this divided by cosine squared alpha minus sine squared alpha all over cosine squared alpha. Alright. Now let's look at the numerator. We have cosine squared of alpha here, and we have a cosine of alpha here. Well, we can cancel out a cosine of alpha in the top and bottom, and in the numerator we can get 2 times sine of alpha over cosine of alpha. Now in the denominator, if we divide everything by cosine squared of alpha, we get 1 minus sine squared alpha divided by cosine squared of alpha. Alright, well this should look familiar. We said that sine of an angle divided by the cosine of that angle is equal to the tangent of that angle. So let's rewrite this And in the numerator, we can say this is 2 times the tangent of alpha all over 1 minus, now sine squared of alpha divided by cosine squared of alpha. Well, that's the same thing as the sine of alpha divided by the cosine of alpha and the whole thing squared. So this is just equal to tangent squared of alpha. Alright? And what did we say that tangent of 2 alpha was before? It was 12 over 5. So this whole thing is equal to 12 over 5. We also said that tangent of alpha was x over 60. So let's plug that in here. 2 times x over 60 over 1 minus x over 60 squared equals 12 over 5. Alright, now we can cross multiply. We can get 5 times 2 times x over 60 equals 12 times 1 minus x over 60 squared. Alright, let's simplify this a bit. On the left-hand side, we get 10 times x over 60, which is just x over 6. So we can rewrite this as x over 6 is equal to, now let's distribute the 12 on the right-hand side. 12 minus 12 times x over 60 squared, which is x squared over 60 squared, which is 3,600. Alright. We can simplify this a bit further and say x over 6 is equal to 12 minus x squared over 300. This should look a bit familiar. We are approaching quadratic form in this equation. So what we can do is multiply this entire equation by 300. And this we can multiply by 300. If we do this, we get 300 times x over 6, which is just 50x, is equal to, if we distribute the 300 here, we get 3,600 minus x squared. And if we put this in standard quadratic form, we get x squared plus 50x minus 3,600 equals 0. Right, now let's solve for x using the quadratic formula. And the quadratic formula is, if you have an equation, let's say ax squared plus b times x plus c equals 0, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug in those values. In our equation, x is equal to negative b, and our b value here is 50, plus or minus the square root of 50 squared minus 4 times our a value is just 1, and our c value is negative 3,600. And all over 2 times our a value, which is 1, so we'll just leave the denominator at 2. Alright, if we simplify this, we get negative 50 plus or minus 2,500 plus 14,400 all over 2. Let's simplify it further. Negative 50 plus or minus square root of 16,900 all over 2. And the square root of 16,900 is 130. So x will be negative 50 plus or minus 130 all over 2. However, we can only take one option. And since we're solving for x, which is the side length of a rectangle, we know that the length of a rectangle can't be negative, so we must take the positive answer. Therefore, x is equal to negative 50 plus 130 all over 2, which is 80 over 2, which is 40. And that's our answer. Thank you for watching this video. If you liked it, please consider subscribing to our channel.